all you gotta do is just tap it in. Just tap it in now. Just tap it in.
Tap it in. Just tap it in. Give it a little tappy. Tap, tap, tap-a-roo.
When it comes to 3D printers, there's a lot of different options out there when it comes to bed probes. And just like multi-material printing, there is no perfect solution. However, there's always room for improvement and new things are always coming out. And in today's video, we're going to be showing you how to install the Voron TAP. Now, what is Voron TAP? Well, essentially, it allows you to use your nozzle probe itself as the probe of your printer by taking your tool head and allowing it to shift upwards. Now, normally you don't want your tool head moving around while you're printing, but using a combination of a good quality MGN9 rail and magnets to help stabilize it in place, it keeps it steady while you're printing and allows it to still actuate to trigger the optical end stop for your probing. And when it comes to using an optical end stop, this gives you some advantages. One, it's not susceptible to heat drift like inductive probes, and it's extremely accurate. In fact, on this machine in testing, it's as accurate as a single micro step. Also now, because your nozzle is the probe, this opens up a lot of different options for your bed surface. One, you can go back to using non-conductive materials such as glass or mirrors as your bed surface. You can even get creative and use carbon fiber if you want now. And two, because now you are actually reading the surface of the bed, you can get more accurate first layers. With inductive probes and those style of probes, you're actually reading the metal surface, not the layer of glue on top of it, not the PI on top of that. You're reading the metal below that. With TAP and other physical methods of measuring your bed, you are actually reading the surface that you are printing on. So I've already got TAP installed on my Trident here. So let's rewind the clock a bit and I'll show you how the install and configuration setup is. So just a quick note of compatibility with Voron TAP. It is only compatible with rigid bed setups. So if you're planning to mount this on a switch wire, it's not going to work. You need a Voron Trident or Voron V2 with its rigid bed mount. Also, when it comes to your X rail, if you are planning to put this on an older build that has the dual MGN9 rails for your X-axis, you're going to have to upgrade them to the single MGN12 rail for the X-axis. Voron TAP is only compatible with the MGN12 rail setup. So let's talk about the hardware I'm going to be using. I am upgrading an existing build, so I'm going to be using the LDO TAP upgrade kit here. It comes with the rail we're going to need. It comes with the PCB with the photoelectric sensor. I'll talk more about sensors later. And it comes with all the screws and fasteners you're going to need for this upgrade kit. Pairing with the Drop Effect XG hotend that I was previously using. You're also going to need all your printed parts. At the same time, I'm also going to be upgrading this tool head to Clockwork 2. To note, if you are upgrading from an afterburner style tool head, the extruder's on the afterburner mounted from the rear. You're going to have to upgrade to either Clockwork 2. So if you're running something that has like an LGX, an Orbiter, or any other third-party extruder, you may have to print a new mount to make it compatible with the Stealth Burner / Voron TAP setup. So I did fully assemble a Voron TAP kit already on a live stream. So if you're looking for the full assembly of it, unedited, I'll link to that live stream below, but I'll just touch on the key points while I put this together. So the first things first, you're gonna have your printed parts. Now these 4 parts here, you're gonna print all the time. And when it comes to the sensor, there are 3 different types of sensors for the Voron TAP. Most kits, and pretty much all kits I've seen, come with the PCB based sensor. So that's the one I printed here. So depending on whatever sensor you're going with, you're gonna print the version of this part here for the mount. Now, all these parts are like all Voron parts where you print them without support. However, these parts do have support designed into them. So we're going to have to remove that support first. If your printer is pretty well tuned, it should come off with no issue. And next we need our rail here, and we're gonna actually have to take it off the carriage. So this LDO kit here does have some little tabs to hold it in place, so it doesn't come flying off prematurely. We're gonna have to remove those. Be careful not to send your carriage flying. And we have this printed retainer here. So what you're going to do is you're going to slide the rail off as you slide this retainer on. There we go. And put it somewhere safe where you're not going to drop it on the floor. Now again, if you are self-sourcing this, you're going to have to cut this a specific way. There's a printed jig for it, but most of the kits come with this pre-sized. Next, we have our 2 magnets that we're going to install into these 2 pieces here. Now, orientation doesn't matter, and we're going to put a drop of glue at the bottom here to keep these from falling out. The manual calls for super glue. Really any glue can kind of work here. You really want these down at the bottom. Now, if your printer is good, you should just be able to push these in, make sure they are bottomed out. Again, orientation doesn't matter. If you have to use something like channel locks to squish them into place, do so, because you really want to make sure these are seated correctly. Next up, we have a bunch of heat set inserts and a single M3 nut we have to install. So let's go ahead and do that now. Again, follow the manual for where to put these in. With the two magnet holder parts, there's a hole that goes right through it. One opening is larger than the other. Make sure you install the heat set on the larger opening side. Now for this piece, the two heat sets install from the back here. And you can see, if you look at this part, you can see this little lip here. When you install your heat sets, the top of the heat set has to be even and flat with that little lip. Like so. And lastly, we have a single M3 hex nut that we have to install up top here. And it may be a little snug, so what you can use is just a screw to pull it through. Now, be careful doing this though, because it's pretty thin here, and if you over tighten your screw, you can actually damage the part. But good thing I printed a spare, because I totally intended for that to happen as a demonstration on what not to do. So now we need to attach these two pieces together using some M320 screws. Then we have two M316s to install here. Now these screw into plastic, and these are for indexing your hot end mount. Now, when you screw these in, you don't screw them in all the way. You leave about 2.5 millimeters here of them sticking out. And this is for indexing your hot end mount. So if you have one printed in handy, you can use it just to verify that everything is in the correct position. You also want to make sure these screw heads right here are below the surface. Now it's time to install our sensor. So since this is a kit, most of the kits come with a PCB here, and we're going to install it right here with M3/8 screws. There we go. Now, the PCB isn't the only option for the sensor for Voron TAP. You can also use a clicky switch or the sensor by itself with some resistors and the wires to make it work. Most of the kits come with the PCB sensor, so that's probably what you're going to be using. If you want to know more about the other options, check out the manual or the website. Now we have two M3/6 screws. These are flathead screws, and these screw into plastic right here. These are what the magnets are going to be working on later. So just be careful installing them that you don't rip the thread out. Flip it over now. We have two M3 button head screws that we install at the bottom here. And now we're going to install our magnet pieces. So when it comes to installing these parts look similar, but there is a slight difference. One of them has one notch on it. The other one has two notches. So the one with two notches, if you're looking at it from this direction, goes on the left, and the two notches are up towards the middle. And the opposite is true for the other one. So heat sets are facing towards the middle, and the notches are towards the top. Again, reference the manual to make sure you install these correctly. And now we got these two M310 button head screws, and we are going to screw these into those magnet pieces with them all the way at the bottom. So it's going to go through that hole that goes through it into the heat set, and just have these slightly snug for now. Again, with these all the way at the bottom. We're going to be adjusting these later, so they're good enough for now. And now to install the rail, it's quite simple. It's 3 screws, but every screw is different here. So we're going to start, we have an M3/6, an M3/8, and then an M312 with a heat set. So I'll show you that in a minute. So let's install these. We got the M3/6 at the top. That screws into our M3 nut. M3/8 in the middle. This screws into a heat set. Now the M312, before we install it in that last hole there, we're going to install the heat set on it as a spacer. So just screw it in all the way till it bottoms out. And we're just going to screw that in. Now you want these 3 screws good and tight. Don't overdo it, because again, plastic, you don't want to deform it. But your entire tool head is riding on this rail, so you want to make sure it's securely mounted. At this point, if you were using a switch on your x-axis, for your end stop, you would install that now. I'm not, so we're not going to worry about that. And that is pretty much it for the pre-assembly. So now we can move over to the printer and start installing things. Okay, so now we're ready to install this in the printer. So the first thing you're going to want to do is you want to ensure, because we are going to be playing with the belts here, you need your tensioners backed off all the way, because the first thing we're going to be doing is attaching this part here to our MGN 12 carriage. And before we do that though, we have to feed the belts through. So make sure your belts, you're feeding them through the right one. There's 4 belts, a top and a bottom one on the left side and right side, and they feed in through the back. So what you can do is feed all 4 in from the back and get them all kind of started. Just sort of get the screws started for mounting and then pull the remaining slack in. Now the reason you don't want to tighten these all the way is so that you could still grab onto your belts and pull them through and just get much tension as you can on them right now before locking everything down. And then afterwards, once it's all built, you can use your idlers here to adjust the tension and walk it in to where you're happy. And then once you're happy with everything, go ahead, tighten the screws all the way. Feed the excess belt back through. Now we're going to go ahead, reinstall our carriage. Take the time before doing this though to make sure everything's greased or oiled up to your preference. If you line up everything properly, you shouldn't lose any of the balls. There we go. And then we go ahead and attach the front piece here using M36 screws, button heads, and they do have a washer on them as well. And with that installed, you can do the first real function test. It should be able to move up and down, and it shouldn't come off the rail if you assembled it correctly. And if you have excess belt, now is the time you can put it through the clip here if they're long enough. But since mine's a rebuild here, I kind of already trimmed my belts maybe a little too short originally, so I can only do so much with them. So I'm just going to trim off some of the excess here. And that now is basically it for the tap portion of the tool head assembly. When it comes to mounting your extruder and your hot end, it's pretty much the same as the regular rail. So follow your assembly manual to put your hot end assembly together and put your extruder assembly together and mount it. So I'm just going to quickly fast forward through that because that would be the same as pretty much any other standard Voron build. And then we'll come back when it comes to actually wiring this thing up and connecting it. Now there's one last thing we have to do with the mechanical assembly of Voron TAP now that we have the entire tool head assembled. And that is, remember these 2 little screws here that attach to the little parts with the magnets? Well, what you're gonna do is you're gonna loosen them up and they should snap into position. And then once they snap into position, you're gonna tighten them back up now. And what this is doing is it's setting the magnet that holds everything together in position. So now, when you push on it, you should feel a clean break. Like it shouldn't just move up the moment you push. It should require a little bit of force and then it'll snap up. It's not a ton of force, but it's enough to keep everything in place while it's printing. And that is it for the mechanical assembly of Voron TAP along with the rest of the Stealth Burner toolhead. Now we got to go ahead and do the wiring. So I'll start talking about that. So my Trident build here is pretty much a stock build. I don't have a toolhead PCB or anything. Everything's wired in directly through the drag chains. So we've gone ahead and removed the inductive probe. It's no longer needed. And for the OptiTap PCB board, the wiring is pretty much exactly the same. You have a voltage in, a ground, and a signal wire. So what I've gone ahead and done is made this little jumper cable here. One side plugs into the OptiTap board and it plugs in right where the probe plugged in before. So there's a few different styles of switch. There's a micro switch and the PCB. So your wiring will differ a little bit depending on what your setup is. If you're running a toolhead PCB board, you're gonna have to wire it in differently. But again, it just needs voltage in, ground, and signal. Now be aware, some of these PCB boards, depending on which revision you have, are only 5-volt compliant. Some are 5-volt and 24-volt compliant. Those ones are really the ones you want, because if you're running a stock setup such as this with a 24-volt probe being fed 24 volts, this is a straight drop in. You don't need to go under the hood and change anything. There is a revision of the board, the 2.1, that does have a defect with it. I have those boards and I'm using them. I am running them at 5 volts though, which the controller board I'm using for this build allows me to select the voltage for this wire. So I'm gonna run them at 5 volts. I've been doing it so far without issue. Read the Discord pin about it. but there should have been stop sale on those boards, and the future revision shouldn't have that issue. So we've got everything wired up. Now we can close it up and we can go over the computer and actually set everything up. But before we get to that, I just want to take a moment to thank those that help support the channel, the content I create, and the things I do. I would not be able to do it without your continued support. And if you would like to help out, consider becoming a member of the channel, a Patreon supporter, or simply just liking that smash button and subscribing. Cheers. So now it's time to move on to everyone's favorite thing and set up the software for this. And it's actually not too complicated. Again, this machine is a fully stock Trident build. I'm not running anything fancy like clicky or any other sort of probe. It just had the standard inductive probe. So my config is pretty much standard. And when you go to convert a standard config to a Voron TAP config, this is the things you have to change. So if you're building stock, you pretty much just use the stock config with these changes. If your machine is set up for something with clicky or some other probing method, you are gonna have to go in and change a few more things to make it compatible with TAP. The actual setup for TAP is relatively simple because now instead of having a probe in the tool head and then a separate Z offset switch, it's just a single probe in the tool head. So we'll just go through the list here and update things as we need to. So under stepper Z, we'll need to comment out the position end stop and change end stop pin so that it's a virtual end stop. Now, depending on how your config is set up, you may find that outside of the stepper Z section, if you did one of the auto calibration features, so it's down here on mine in the pre-generated section, so we're just gonna delete that. Our end stop pin now, again, is now a virtual end stop. Our safe Z home, it's now no longer the position of that clicky switch that we use for Z offset. Now you want to set it at the middle of your bed. So I'm going to set it to 175, 175. Now in the probe section, you are going to have to change a few things. Remember now, your probe is the nozzle itself, so there's no longer any offset to worry about. And then there's also a section here we have to add. You can just copy and paste it into the probe section. And this just makes it so that when your nozzle temperature is above 150, you can't probe the bed. Just prevents your bed surface from getting potentially damaged from a really hot nozzle hitting it repeatedly. And once that's done, you just save and restart, and hopefully you get no errors. Now, it depends on how your machine is set up. If you're running a completely stock machine in a new build, it's a relatively simple process to switch over to Voron TAP. However, if you have a ton of pre-configured macros or you're running a non-standard printer setup, you may have a little bit more work to convert your config over to a Voron TAP config. And one of the first things you should do after your config is all set up is just verify that TAP is working. So in the down state, you should see end stop set and probe as open. And when TAP is activated, you can just push the tool head up with your hand, re-pull it. You can see there end stop Z and probe are now activated. So things should be set up there. So what we're going to do here is we are going to go ahead and run a homing test. Keep your hand on the e-stop just in case, and just make sure everything works. So let's just let this run. For things like your bed mesh, remember your nozzle is now the probe, so you no longer have to worry about the bounds of travel because you can now probe your whole bed essentially because there's no offset with your nozzle and your probe. So you can go ahead and adjust your bed mesh sizes to be closer to the actual edges of the bed in all directions to get a more accurate bed mesh. So one thing I do recommend is essentially a break-in with your Voron TAP. And to do that, home your machine after you ensure everything is working and just run probe accuracy samples equal 100. And this will essentially test your probe 100 times. This ensures everything's kind of seated correctly, everything's kind of in the right position. There's no little burr on a plastic part or anything that's kind of catching for a bit. And just let it run before we move on to the next step. And once the break-in is done, just run probe accuracy one more time. It'll do 10 probes by itself. And this should give you a pretty good idea of how well you have your machine set up and how accurate Voron TAP is. So as you can see here, over 10 probes, our standard deviation is only 0.00375 millimeters, and our range is 0.00125 millimeters. Now, the range is kind of important because your accuracy for range is only ever going to be as good as your Z motion is along with your microstepping. So if every single microstep is 0.00 125 millimeters of travel, that's as fine of a data point as you can really get with your setup. If you go to higher microstepping, higher threaded pitch lead screws, or other Z motion system, you can get more accuracy out of Voron TAP. Voron TAP is capable of being more accurate than really any 3D printer needs, especially since most of us are only running like 16 microstep on our Z travels anyways, but the capability is there if you want to go to even finer, higher detail. So now we've verified Voron TAP. We've ensured that it's reading accurately. We can go ahead, run QGL or Z tilt, depending on your bed setup. Remember, you can adjust your positions now for QGL to get closer to those corners, because again, you no longer have that probe offset. So if you want to change that, go ahead and do that. And the last thing you need to do is just set your Z offset. So again, because you're no longer using that separate Z switch, you could just use the probe calibrate method for setting your Z offset. So just go ahead, set your Z offset, and that should be it. You're ready to go and print. And there you have it. So the actual installation and setup of Voron TAP, in my opinion, isn't as complex as it first seems. Now, as somebody who has built Vorons with both the standard inductive probe, clicky setups, and now Voron TAP, I still believe the inductive setup is the simplest method, especially for new builders. But if you're looking for something that's a great alternative and isn't as complex, especially when it comes to macros, as the clicky setup for bed probing, I do believe this is a great option. Now, it's not perfect. It is still a new release, and anytime new stuff comes out, we test as much as we can behind the scenes, but until you have a few hundred people testing it with a few hundred hours on machines, you really don't see what can crop up when you have a wider audience using something. Also, it does add some weight to your tool head. It's not as much as it seems at first, because we are simplifying some of the carriage design aspects, but you are still adding an MGN9 rail to your tool head, but you are still adding weight. So make sure you run your input shaper tune afterwards, and you may need to lower your acceleration values just a little bit. Now, when it comes to getting the most out of Voron TAP, it really depends on a machine that doesn't have any underlying issues. If you have cracked parts, worn belts, wobbly idlers, you may run into issues with the accuracy with Voron TAP. And one of the biggest things that can affect how well your printer performs is how good your frame is assembled. So I'm going to link a video right here that goes over how to ensure that you're building your printer frame that's square and true. I hope you enjoyed the video today. I hope you learned something new. And as always, cheers.